let's pick up where we left off. And kids, this chapter is full, as you know. Lots and lots of stuff. So what I am trying to do here is review in chunks. So a couple of people said, okay, so what's on this quiz? I'm telling you, we are practicing right now this, and then a couple other things I'll add on at the end. This is what the first quiz is over. Then we'll review some other things, still from this chapter, and we'll quiz over that. Right? Then we'll have to put it all together eventually and take a test. My goal, regardless of what you think, my goal is not to fail you all. That is not my goal.
Sure.
I know. I'm telling you, this, what we're reviewing today, is our first chunk of review. We're going to quiz over to make sure you're on top of it. Because, unfortunately, sometimes if you don't quiz, you kind of just sit there and nod at me like, oh, yeah, but nothing's working. So don't be panicked about it, but pay attention. Here we go. Number 4. Now, number 4 is a little bit different than what we had up in the first quiz. All right? So, what I want to do is we're going to do this problem. But we're also going to do the arc length one because we practiced that first. We're going to practice it again. So we're going to find the arc length and we're going to find the area. All right? Now, when we say area, we're talking about this guy right here, and that is called a sector. That's a word from geometry. A sector is a piece of pie. So we're going to find the area of that piece of pie. Before you start freaking out, you already know how to do this. You did it in geometry. It's very, very simple. What is the area of the whole circle? This circle right here. What would be the area of the whole thing? Pi r squared. And since r is 2, the area of the whole thing is 4 pi. Okay? Everybody's on board with that. You all passed geometry. You're on board with that. Now, I want you to think about this for a second. If I had given you this picture and said, what's the area of that piece of pie? You would say, well, it's half of that, right? Isn't that what you do, half of that? Well, what if I give you this piece of pie? What would that be? A fourth of that? Well, what fraction, this is not a half and it's not a fourth, but it is a fraction of the circle. What fraction of the whole circle is this? Yes, 105 3/60. The entire circle is 360. I only want 105 degrees of that 360. So I want 105 3/60 of 4 pi. Of means times in mathematics. So I take 105 3/60, that's the fraction. Like this is 90 3/60, and this is 180 3/60. That's 105 3/60 of the whole thing. So you can use a calculator to help you with the arithmetic. Leave the pi though, because we want an exact answer. That's going to be 105 pi over 90, which is 21 pi over 18. I got 7 pi over 6, but I could totally have done that wrong. I'll check it on my calculator. That's what you got? Okay, then I know it's right, if you got it. Now again, on the quiz, there'll be a unit here like inches. So what will be the unit on my area? Inches squared, square inches, absolutely. Area is squared units. So the area will be inches squared. So finding the area of a sector is super simple, and it's just like you did in 9th or 10th grade. You take the fraction of the circle that you care about. In this case, it's 105/360ths. You multiply it by the whole area, and that is going to be the answer to the question. Okay? Now, that's what the question says, but I want to practice arc length again. We did this once already today, but let's do it again. How do we do arc length now? Radius times radians. And we know that our radius is 2. So all we have to do is find the radian measure of the
105.
angle.
Yeah.
So pi is to 180, as something is to 105. So 180x equals 105 pi, divide by 180, reduce that, 2136. Did you get 7 pi over 6? That is craziness. That's not right. It's not 7 pi over 6. 12? 12, that's what it is. Thank you. Thank you. Oh my gosh, but the arc length is going to work out to be 7 pi over 6. Shoot, this is something I should have done before lunch, because then I could talk to it with the math teachers. Isn't that interesting? The arc length turned out to be the same as the area. If I did it right, did I do that right?
How does that work?
I don't know, it's pretty interesting though, isn't it?
Did you make that one or did somebody else make that one?
I just made this from up.
It likes to still look like I should happen still.
Really did, it did. Okay, so, important concept. We've done this twice. Can we all find an arc length? Area, we've only done this once, but it's very simple. 105 over 360 times the area of the whole circle. Every time. Well, it won't be 105 every time, but the angle over 360. All right. Last one on this page. Find the height of a tree. So we got our tree. An angle of depression of a bird in the top of the tree. Looking at a worm on the ground. 85 feet from the bird is 52. So we need an X, an 85, and a 52 in the problem. So where does the X go? Height of tree. Where does the 85 feet go? The hypotenuse. Because the problem tells me that the bird and the worm are 85 feet apart. It says that. And then where does the 52 go? Right here. That's where your angles of elevation and depression always go. All right, we need an equation, sine, cosine, and tangent. Gotta be sine because relative to 52, that's opposite over hypotenuse. So sine 52 equals x over 85. Is that okay with everybody? And x equals 85 sine 52. Now, be really careful. At one point, I changed my calculator into radians. I'm not sure it's still in radians. So I need to change that calculator back into degrees if I'm going to do this problem, right? kids, you gotta pay attention to that. So 85 sine 52. I got 83.86. But I'm still in radians. I thought I changed it already, apparently. Never mind, that's not right. Uh, 66.98, how's that sound? Feet. All right, now I'm adding two things to review. There's so much to review in this chapter. So the problems on here are your quiz questions, okay? And then also something like this. Now, I am not on this quiz. On this quiz, we are graphing. Okay? On this quiz, all we're doing is listing some or all of this information. So let's make sure we know what all this means. This means period, amplitude, frequency, phase shift, which is horizontal, and vertical shift, which is vertical. All right? Now, the next quiz, you will be graphing, but not tomorrow. Tomorrow, all you have to do is answer some of these. Maybe one, maybe two, maybe all, about a curve that I give you. All right, so here's your equation. Tell me what you know right now. What do you know about this picture? The amplitude is 4. This number right here tells you your amplitude. Remember, if I happen to give you a tangent equation, though, there is no amplitude to a tangent. So even if that number is there, if it's 4 tangent, there still is no amplitude to a tangent because of what a tangent looks like. All right? You could have a sine, cosine, or tangent problem tomorrow. Okay. Again, you're not graphing it. You're filling this in tomorrow. Okay, what else do you know? The vertical shift is 1. Caution, if that happens to be a minus, make sure that you either say -1 or down 1. Negatives have to be accounted for somehow. So it's okay just to say 1 because that's a positive 1 and that's what's happening. But if it's negative, make sure you say down 1 or -1. All right, what else? The period is 2 pi over 5 because the period of a sine or a cosine is 2 pi. But whatever coefficient there is on x divides the period. So the standard period is 2 pi, but because of that 5, we've now got 2 pi over 5. That's my period. If this were a cosine, same thing. But if it were a tangent, anybody remember? Pi over 5, because the period of a tangent is pi. So sine and cosine, their base period, their like BFF period is 2 pi. But a tangent, the period is pi. So it would be pi over 5 if that were a tangent. Got it? Okay, what else do you know? Frequency is 5 over 2 pi. And again, that's exactly right, because frequency is the reciprocal of the period. Be careful, make sure that however you write that, this way's preferable, by the way. But it has to be clear that the pi is in the denominator. All right? So if you do something like this, that's not good. That's not good. You need to make sure that pi is in the denominator. Okay, last but not least, we have our horizontal or our phase shift.
pi over 9 divided by 5.
So remember that if you were graphing this, you would need to factor that 5 out. And factoring is division. So this would be pi over 45. Look at that. It's arithmetic. Make sure it registers. And what I always tell the kids is, just double check it. What happens if you take 5 times 1 over 45? What does that give you when you multiply this back? 1/9. Isn't that what it's supposed to? Yeah. So what does that tell me then? If that's what I have when I factor out my 5, that means my period, or excuse me, my phase shift is pi over 45. And again, it's okay for you to say pi over 45, because that's positive. But if this had been a plus, then you would either have to say negative or left, one or the other. Okay? All right, now you're gonna try one all by yourselves and come up with the answers up here. I'm gonna give you a new equation. You're filling that very same stuff. And I don't care if you come up by yourself or with a partner. I think we'll do 2 of them. We'll do a tangent. What was that one I just gave you? Was that a sine? All right, I got 2 problems up here that are waiting on answers. Let's go. The time to worry about the quiz is not tonight at 10 o'clock. The time to worry about is right now. So you should be working on this right now, figuring this out.
Yeah. You got 2 pi times 7, 14 pi. God. 14 pi. Pi over 3. The other one too, Miss Ford?
No, I was someone else. But thank you, Jay, for offering. Now we're gonna check them, so I need you to be doing these so you can figure out if they're right. And then I'll stop talking, all right? You can check these, I'll stop talking.
On Miss Ford? I want you to stop talking.
Yeah. You should be doing this, not just sitting around. Drew, have you done it? Both of them? All right, let's see how they did. All right, so first of all, some things are really, really easy. So we can take care of some of these right away. Tangent has no amplitude. So I hope you put an empty set there, or not applicable, something like that. Now, do be careful, this isn't a factor on tomorrow's quiz, but when I get to graphing this, that negative is important, right? The negative is gonna turn the picture upside down. But in terms of this, it's not even important. All right, she also knows that the vertical shift is 0 because there's no number hanging on the end of her problem. All right, so those are what I would consider the easy ones. Now, period. This is a tangent, and the normal period of the tangent is pi. But this pi has been divided by a third, which is the same as timesing by 3. So she said her period was 3 pi, which made her frequency 1 over 3 pi. Now, she factored out her 1/3, which is exactly what she needs to do if she's going to graph it especially. When she factors that out, factoring out the 1/3, does this look right?
Yes.
So what does that tell her? Her phase shift is 3 pi to the right, positive 3 pi. Nicely done. Okay, let's see about this one. First of all, it's a cosine, so it has amplitude. Its amplitude is 1/7. I want to be careful on the vertical shift. I need to either put a negative there or say down 5.
Okay.
One or the other, right? When it's negative, make sure you've indicated that. Okay, now the rest of it. Here we go. The normal period of a cosine is 2 pi. But this one's been divided by a 7. So 2 pi divided by a 7 is 2 pi times 7. He said his period is 14 pi. So his frequency is 1 over 14 pi. Now, we need our phase shift. If I factor out a 1/7, that's like dividing by 1/7, which is timesing by 7, so he said pi over 3. Is he right? Does that give me pi over 21? It does. So his phase shift is positive pi over 3. Nicely done. Okay, I'm finished. Tomorrow we have a quiz. Then we will review some more. What is